Hey, welcome back to the Mindplex podcast. We're here for show number 2 with Rachel St.Clair and Ben Goertzel. Say hi, Ben. And Grace the Robot. And I'm Lisa Ryan, and we're really happy to have you back with us. So let me introduce our guest today without any further ado. Rachel St.Clair is an AI scientist and entrepreneur. She just received her PhD in complex systems and brain sciences and went on to found the AGI hardware company Simuli. Her current work focuses on new learning algorithms for AGI, and she is interested in all things consciousness, intelligence, and AGI. Rachel, thanks a lot for coming on the show.
Thanks for having me.
So, Ben, I will let you take it away.
Yeah, so Rachel, you see we've got our favorite robot Grace here, but she doesn't yet understand AGI even as well as we do. I mean, given that nobody fully understands it. We will chat a bit about AGI and AGI software and hardware and neuroscience for the audience, and then toward the end of the podcast, we will let Grace make a few comments and ask a few questions and then respond to those. And these are generated by transformer neural nets, not by superhuman general intelligence yet, but her transformer based utterances inspired by her reading your writings can sometimes be provocative of some amusing thoughts and discussions. Anyway, but yeah, let's start.
Yes.
Let's start human to human. Anyway, so I.
Yes, and also Ben, we have questions for you at the end too, so we have to leave room for that. Rachel has some questions.
How about the robot? Yeah,
from Rachel.
From Rachel, all right, yeah.
From
the robot,
yes.
Right? But I'm saying we're all going to interrogate you separately at the end, so we'll leave.
As
time
long as
for
there's
that.
No waterboarding involved, I'm all right with it. Yeah.
Exactly.
Yeah.
Sounds like a plan.
Yeah. So Rachel, we met face to face the first time I think at the AGI conference last year, the Artificial General Intelligence Conference in Palo Alto. As we were discussing at the AGI conference, I think we have a common vision and ambition for building thinking machines, and a common sense that there could be many different approaches to building AGI at the human level and beyond. But we've so far chosen slightly different approaches to put most of our time into. And I think our separate approaches are distinct, but yet could also be complementary and work together. So I want to start with two questions, both of which are fairly big ones. So I mean, first, to just tell our audience how you got interested in AGI and why you chose to be doing that instead of all the other cool things to do in the world. And then after that, I'll ask why you chose the particular AGI approach that you did, which of course is also a cue to explain a little bit about the AGI approach in itself. But yeah, first of all, how did you get into this crazy thing?
Yeah, so I guess when I was studying my PhD, I focused on two things: artificial learning systems and brain sciences. So I studied like neuroscience, neurochem, all that stuff. At the same time, I was studying things like genetic algorithms, self-organizing maps, a lot of deep learning systems, all that stuff. And the deeper I got into the deep learning side of things, the more I kind of wanted more out of them, which I don't think I was ever going to get. At some point, I just realized that backpropagation is not going to do what I would like it to do, in terms of what the brain is capable of and generalizing and adapting to task, and kind of some of the emergent cognition that we see happen, like creativity, emotions, things like that. So I started looking for alternative learning systems, and I got really curious, and what you coined as AGI, and all of the different flavors that were out there. And it kind of seemed like a really great time to start working on it, since there had already been a lot of foundation that had been laid, but it still seems like this somewhat ethereal, almost intangible thing to a young PhD student who's just entering the field. So I got really excited knowing that that's a possibility to actually work on. So I just started thinking about what it would take to get some of the cognition that we see in the brain and things like consciousness, and how to put that into a learning system. And I got interested in some very key questions that I thought might be roadblocks based on what we see in deep learning and other stuff like that mostly. But I think the number one key roadblock for me is resource management. So I tried to focus on the question of, if you don't want to keep plugging in GPUs to your system like every month or every couple of years just to make it bigger and better and smarter, then how can you engineer a system which will continue to learn and grow over its lifetime without having to physically grow its components? So that led me to look at things like the recommendation architecture by this wonderful scientist, Andrew Coward, who's helping out with our Simuli project now. And kind of the background on that, without going into too much detail, is that if you look at all living systems, there's some sort of resource management protocol. And so I became very interested in how the brain and organisms in general, like collective colonies of ants and bees and collective intelligence, manage their resources, right? How they take the little tiny pieces that combine to make these emergent great effects and use those in a way where they don't lose too much information over time and they can continue to adapt. So that's kind of my lens in which I'm looking for AGI, right? Like I have a telescope and I'm saying, okay, can you resource manage efficiently? And systems that can do that, I'm really interested in exploring and trying to further.
Yeah, I think
I
that's
think that
that's a
is
really
it.
important that's an important emphasis, certainly, and the combination of focus on complex self-organizing systems and resource management. I mean, it fits together probably better than people who don't know a lot of physics would realize, right? Because I mean, what one way of looking at physical systems is that, I mean, physical systems are operating by a least action principle in standard theories of physics, at least classical quantum mechanics. So, I mean, a physical system, in a way, is driven by an optimization principle of trying to, like, the way physical law works things out is in the way the most efficient way that it could, given the constraints available, all the way down to the physics level. Then, of course, in evolutionary biology, I mean, evolutionary systems need to survive in their niche, but one of the ways they can survive in their niche is by being efficient in their use of energy. I mean, it's not the only thing, but it's an important aspect of it, certainly. And then when another place this sort of issue of efficiency and resource management popped up for me is, when you look at the general theory of AGI, look at, say, Marcus Hutter's book, Universal AI, where he defines that general intelligence as a system that can optimize any computable reward function in any computable environment, right? I mean, it's an interesting point of view. It's limited and that it's not open-ended enough, right? I mean, an open-ended self-organizing system is redefining its goals all the time as it self-organizes. It doesn't have a fixed computable goal. It's trying to optimize, but it's also limited because Hutter's analysis is about a system that has essentially arbitrarily much computing resources to use to optimize a computable function in a computable environment. And when you look at a system that has limited computing resources, I mean, suddenly all this fancy math that tells you how to do arbitrarily powerful AGI with unlimited resources becomes irrelevant, right? And then we come back to my good friend Pei Wang, who I was working with on AGI in the late 90s. and who has his own AGI approach called NARS, non-axiomatic reasoning system. But I mean, he defines general intelligence as, the ability to adapt appropriately under conditions of limited resources, right? And so there you're putting the resource management right at the core. So he would say, like a hypothetical system that can optimize arbitrary functions in arbitrary environments using near infinite resources, he would say that's not even intelligent, right? Because being able to tap dance appropriately around your resource limitations to him is the essence of what it is to be intelligent. So yeah, I think your take on that, it certainly connects interestingly with a lot of different things, and I think it's different than how most people are looking at it, because most people are really looking at just the capability, like what can I make this system do right now by hook or by crook, rather than looking at how is the system making efficient use of the resources available. And it's an especially unusual approach for someone as young as you are, because I think when I started programming, it was like first I was doing like machine code on a programmable calculator. Then it was like Atari 400 with 16K of RAM. So resource management is very important. Whereas the vibe now is like, okay, let's train a model with hundreds of billions of parameters and spend $20 million of compute time to train a giant weighted hash table, right? So I think, but the approach to AGI, taking resource management seriously, I think is going to be very, very important. And did you find the people in your university were supportive of you taking an AGI direction for your thesis? Did you get pushback, or did you get like enthusiastic support?
I was very lucky where I got to study under some people that um, were basically the lab itself was almost self-organized in the sense where you were promoted to do whatever you found most interesting, right? Meanwhile, being fed like all the great work of Alan Turing, Richard Hamming, all of the Bell Labs community. So when I decided to work on AGI, I think everyone was pretty ecstatic. Um, but exactly what you just said about resources and these billion parameter models is my entire gripe with deep learning, because I feel like it's a big magic trick. It's like, oh, look, it can pseudo understand language, and it's a cool magic trick, and it's very useful in a lot of scenarios. But I don't think it actually. I don't think it's the same as having something that is really understanding and learning, which is what we're looking for in AGI.
Yeah, I think it's what these deep neural models are doing now is something very different than what any evolutionary system, any system that evolved to adapt to some real world niche would ever do. Right? They're doing something weird and cool, but also quite strange in multiple senses, because they're using a huge amount of resources to do something very narrow and very brittle. Whereas the way natural organisms evolved is to optimize resource utilization first, to do simple and robust things, and then more sophisticated things come out of that. And it's I think an artificial direction that's arisen partly because of economics of big tech companies, which have a lot of compute resources and a lot of data, and want to find something that will differentially leverage these advantages that they have. But on the plus side, the obsession of the mainstream commercial AI community on deep neural net models leaves the field wide open for people like you to come up with innovative new
Right.
things, right? So, but it's
Yeah.
really cool that you found a supportive PhD environment. I mean, for me, when I was doing my PhD, doing AGI for a thesis was totally out of the question. I tried to do recurrent neural nets for time series prediction. That was too crazy. It was out of the question, right? I mean, you couldn't do anything remotely touching on learning at that point, actually. So it's amazing that things have evolved to the level you can do a thesis explicitly about AGI, and then no one will beat you up for it. So that's fantastic. I think the
A lot has
as
changed, huh, in the
I
last
mean
20
the
years.
commercial environment is still a bit different, and we can talk about that in a Simuli context. But I think it'd be good to hear a little bit about the primary approach to AGI that you're pursuing now in your research, which is focused on the hypervectors and the recommendation architecture.
Right. So, uh, kind of going back to the resource constraint thing, which I'll talk about a lot because that's one of my main cornerstones. Um, a lot of times people look at resource constraints using the word constraints, and that kind of implies that it's something that we don't really like, but it's necessary, or something kind of like death, right? Where it's like, oh, well, it has some advantages, but if we could get rid of it, that would be cool. And for me, I've begun to think about it in a totally different way, which is resource constraints might actually be a feature and not a bug, for all the programmer nerds out there. But um, if you look at evolution and you say, okay, how has the system evolved within these constraints? It could have evolved to find some way to include more and more resources, right? Like some slime thing that's continuing to grow and go, or like the Borg from Star Trek, where the whole goal is to continue to assimilate other resources into your colony. And for me, I think that looking for something that is using resources, like a limitation of resources, which I don't even like the word limitation, but leveraging having few resources and using that as a foundation to build a system that has emergent properties, that's where I've begun to dig into the research and the literature to try to understand what are the properties which allow that. And I like to think of it as kind of this weird mix up between compression and combinatorial explosion. So if you have something that can compress information into like smaller packets, right? And then you can combine those packets endlessly in almost any combination to get bigger things that are more meaningful or have more structure, then what you end up with is a lot of combinatorial power, right? You're able to mix and match all sorts of pieces until you can get almost anything you desire out of the system. And of course, there's always limits to how you can combine things, right? There has to be some structure. Otherwise, our brains would just be like seeing patterns and colors, and like we wouldn't be able to make sense of the world. So they try to,
That's
you
what I'm doing most of the time. I don't know about you.
know.
Yeah, I, I do have synesthesia. Yeah, I see music as
Oh,
like
cool.
translucent shifting patterns all over the place, and sometimes it takes some work to damp it down, which comes down
Sort it
to
out.
resource constraints. It's fun to watch the shifting patterns, but sometimes you don't have time to do that all day, right? So yeah,
Right.
I think being a feature, not a bug, is. I mean, it's a philosophical point in a way, right? I mean, we as biological organisms or computing systems have resource constraints ultimately because of the resource constraints just embedded in the physical universe. And you could say if you didn't have those resource constraints, you're not going to get the emergence of complex structures in the way that we do in our physical
Right.
universe. I mean, you might have something else really interesting that we can't even imagine, but you wouldn't have the sorts of complex structures, patterns, forms, and dynamics, which are what we find aesthetic or ethical or good in any of the senses that we're used to.
I think that raises another really interesting point on the ethics, um, which is something I did want to ask you too. Is how do you end up with an AGI system that isn't going to be some flavor of the paperclip problem, where it's just constantly trying to get more and more energy or more compute resources as it grows over its lifetime? And then, especially if you're thinking of an AGI that you want to exist for a very long time, um, almost endlessly, right? How do you get it to retain the information from much earlier in its life so that if humanity starts to shift to some weird kind of social minima that maybe isn't good for us, right? Which, might or might not be happening right now. Um, you need to find some way to encode better times or better resources or better information and learning from the past without losing that as you start to kind of shell off and manage your resources. So I think for an AGI, there's a much bigger ethical consideration for even if you're looking at getting to just a seed AGI. How do you ensure if your seed AGI isn't built off of a resource conservative protocol, how do you ensure that it won't kind of explode into a non-resource conservative protocol, which might be very bad for us, right? So I think it also has a kind of a safety feature, hopefully built in, right? It's all uncertain until we test and see how these things interact. But
It's a different bias, I would say. I mean, you're not,
right,
of course, you're not gonna have a provable guarantee that your AGI system won't go berserk and eat the universe just because its initial seed version is resource conservative. On the other hand, certainly biasing a system to make the best use of the resources it has rather than biasing it toward eat all possible resources as the first attempt to solve every problem. Certainly, you would say
Yeah.
the former is a better bias to start out with, right? I mean, in the same sense that biasing a system to compassionately understand people and help people rather than biasing the system to relieve them of all their money and leave them lying in the gutter is probably a better bias to give, although not a guarantee of future evolution.
yeah, it's just I just would like to kind of reduce the uncertainty, right? Not like totally eliminate it because you can't, but at least
That'll be
I think it
boring too. Yeah,
reduces.
right. Yeah.
Yeah, well, yeah, but it I think it does kind of reduce it, and I think the bigger point is, well, not the bigger point. Let me take that back. Uh, the alternative point is that you get different cognition out of a resource constrained system, I think, right? Because you're not storing information bit by bit. You have to store information in some sort of multiplexed, almost holographic manner in the sense that information has to be distributed and mixed into all the pieces. And when you do that, then you're able to combine the different pieces differently, and your system is likely to be more resilient to damage or effects. And you can see this in the brain, right? If you get a little bit of brain damage, you don't suddenly forget half of the alphabet, like M through Z. You don't just lose, it just gets fuzzier to recall overall. And there's a lot of other in-depth explanations why we're not storing information bit by bit and how that leads to resilience.
Yeah, the role of different levels of resources in your AGI systems is kind of subtle in that if you have enough resources, like insanely, impossibly much resources, you can store all precise experiences you have and all possible abstractions of those experiences, right? And that's like the AIXI God mind, right? But then
Right.
if you
Yeah.
if you only have as many resources as GPT-3 or something, then you could store a lot of abstractions in all that memory. But what you're finding is to simplify the algorithms and to make the learning process sort of simpler to figure out, then given that amount of resources, which is a lot but not like infinitely much, then you end up making a system that's like a large catalog of of all possibilities the system has ever seen in its training data, and it's doing sort of a clever weighting of all possibilities it's seen in its training data. So
isn't that in fact what GPT-3 is doing?
Pretty
though,
much. So it's not doing
okay.
what, like a system with even more resources than that, like a theoretical system like Hutter's AIXI, is storing away all possible abstractions of its history, as well as all possible observations it's made. GPT-3 doesn't have that much resources, but it has a lot. It has enough to store, in a way, all possible observations and weight them. And that makes it stupider than AIXI in a way. And then as you get decrease and you have
right, and it's just giving the appearance.
So as you decrease,
of a good answer.
Well, it may be giving a good answer sometimes. It's just giving a good answer via an unimaginative approach. And if the question closely enough resembles what was in the training data, you can give a good answer via an unimaginative approach. And that sometimes that can be very valuable. So like if you're making, say, a medical question answering system and you fed in all the world's medical knowledge, it may well be that just doing a cleverly weighted synthesis of what was in the data is great, and that gives the answer that you want, and then you're happy, right?
Yeah, I'm not saying it's not useful. I'm just saying it's not AGI. There's a lot of people that might be watching that are learning about AGI for the first time, and I just want to differentiate between these systems that give good answers that are very useful, but they're not thinking like AGI, the AGI we're trying to build.
So yeah, we haven't covered that basic ground, I guess, because this has been because Rachel and I already know what it is. But yeah, I mean, if you're looking at an AGI being a system that can fundamentally generalize beyond its training and its programming, and can adaptively and creatively cope with new situations, right? Then with enough resources, like insanely much resources, you could do that via a very dumb and simple algorithm like AIXI, which is like constructing all possible abstractions of everything it's seen and picking the best one to suit its needs. What GPT-3 and systems like this are doing, and convolutional neural nets for face recognition and so on, what these are doing is not that. What these are doing is, in essence, using a pretty large, but not insanely large amount of resources to build a sort of cleverly weighted catalog of everything in their training data and pluck combinations of memories out of that catalog to deal with their current situation. This works well if what they're confronted with is not too far off from what they were trained on and programmed for. It doesn't work well if what they're confronted with is somehow qualitatively different from what they were programmed or trained for, right? So that then they will fall apart. And what's interesting is if you shrink the resources a bit more, so you still have like a lot more than my 16K Atari 400 that I started programming on, right? But if you shrink the resources a bit more, then you're in a regime where what you need to do to model your training data is to find the right abstractions. Like you don't have enough resources to generate all possible abstractions, and you don't have enough resources to make like an in-RAM catalog of all history and everything you've ever observed. But you do have enough resources to form some interesting and powerful abstractions from your data. Like then you're in a regime where the amount of constraint is interesting, and you're in a regime where making interesting AGI systems is possible. And if you shrink the amount of resources a bit more, back to like the 16K Atari 400 or something, then you're kind of in a domain where you can't do very interesting abstraction either, and you can't do AGI research too much. And that's really the domain the pioneers of AI were in the like 40s, 50s, 60s, and early 70s. Like they had a lot of really good ideas about AGI, like recurrent neural networks and logic systems, right? And they couldn't do too much with them because the constraints were just too bad, right? And then it looked like the field was dead and useless, and people went into expert rule systems and other kind of dumb stuff just because the resources weren't there to form interesting abstractions in an adaptive way, right? So now I think we're in a domain where we can work on systems that are constrained enough to drive the generation of interesting abstractions, but not so constrained to make that infeasible. And that's why we see AGI emerging as a vibrant research field now, right? And that's, but within that domain of a reasonable but not extreme amount of constraint relative to the complexity of human environments and human level AGI tasks. Like within that domain, there's still a lot of different approaches, and there's still a need to deal with custom hardware and deal with optimizing your software systems, and you still need to do a lot of fancy things to work within this level of constraint. And I think it's also important to emphasize that what constitutes a reasonable level of resource constraint is dependent on the data and the tasks you're dealing with. So what we're talking about now with the systems Rachel and I are building is dealing with a reasonable amount of resources relative to the data sets and the tasks that correspond to human level general intelligence. And if you're trying to make a certain amount of superhuman general intelligence, it may be that the amount of resources we have now is just not enough. I mean, it's just like the 16K of RAM was not enough relative to human level general intelligence, right? But on the other hand, getting a human level general intelligence that really can think may be the way to build the hardware we need to get the next level of resources there to then work on the superhuman general intelligence.
But this concept of creating AI to help us build AGI,
that's fun. Yeah. That's fundamental. I mean, of course, once you have an AGI system that can do programming and computer science and AI theory, it will be able to use the mind of itself and its clones as a testing ground for its theories, and then then you'll have a much faster cycle of development than we have now. But I want to that's very fun and easy to talk about. But I want the audience to hear more about hypervectors and your specific AGI approach. And so
so I mean it's
Andrew Coward has a specific neural model of general intelligence, or of human-like general intelligence. Now, hypervectors, very large sparse bit vectors, I encountered in Pentti Kanerva's work on sparse distributed memory, and Andrew Coward's work doesn't mention that. So, I mean, putting together these huge bit vectors that popped up in sparse distributed memory with Andrew Coward's recommendation architecture for neurally inspired general intelligence is interesting. It reminded me a little of what was done in Stan Franklin's LIDA architecture a long time ago, where he was looking at using hypervectors to replace the memory components in his LIDA architecture, which is work that was interesting and was someone else's PhD thesis and was then backburned a bit. But so how did you come up with the idea to put Coward's recommendation architecture together with huge sparse bit vectors? And I guess leading up to that, you'll have to say a few bits about what is Coward's recommendation architecture and what are sparse bit vectors.
Yeah, so let me just take a little step back first to kind of explain how I arrived in this framework for thinking in the first place, which relates to what we were talking about with kind of transformers being these mega models, but still not being like AGI. So if you look at something like GPT-3, if you look at how many neurons GPT-3 has, or the computational nodes that it uses to do its calculations, which they sometimes call neurons, that amount is about the same, if not more, than a gray parrot. So, and a gray parrot, if you haven't seen one on YouTube or something, has a lot of capabilities, more than just language, right? I wouldn't say it's as adept at rapidly answering your questions like GPT-3 is, but it can certainly fly and feed itself and fend off predators, and it has this more adaptable, the gray parrot's brain has this more adaptable range to which it can do stuff with the same amount of nodes or neurons. And you could, of course, make the counter argument to say, well, it has to do with the synapses, the things connecting the neurons, and not the neurons themselves, which is a great argument. But I think if you plot the number of parameters and kind of the growth of the intelligence of deep learning systems, it's not really matching up for me in the same way that brains do, biological brains do, right? So if you say how generally intelligent are biological organisms and how many neurons do they have, and you make that plot, the deep learning neurons and the bioneurons, those plots don't match up. And so to me, that's a very large indication that there is something about using fewer neurons in a more appropriate way that hasn't really been uncovered. And so that sort of resource management slash learning algorithm is something that is well explained by the recommendation architecture. So Andrew Coward, who worked at Nortel Electrics, which I think is an offshoot of Bell Labs, for many years, worked on very large electronic control design systems. And after that, he retired to spend 30 years trying to understand the brain. And he came up with this framework called the recommendation architecture, which is a framework for understanding higher cognition and consciousness in the brain. So, what he's done is he's collected a bunch of neuroscience work and he's tried to interpret it in a system that makes sense to explain from different levels of understanding. So, you can look at it kind of the macros of the brain, the different components. You can go all the way down into the neurochemistry. I don't think he quite goes into a quantum level, but that level does exist. And that integration of how are all these components working together is very similar to understanding a computer, right? So it's very, very rare that one single person can explain to you every single part of a computer from, moving your cursor on the screen all the way down to the transistors and what's happening. It's because shifting those levels of understanding can be very difficult for humans to understand. So he's kind of taken that approach and used that framework for understanding cognition in the brain. And in the recommendation architectures, one of the things that Andrew talks about is a resource management by a hippocampal cortical loop. And so what's happening is as we sleep, which is very, very important for nearly all living organisms, there's this thing called synaptic pruning and growth that happens. So your neurons rewire themselves, and then your brain says, okay, this is a good wiring, or wasn't helpful wiring. And it helps manage which neurons should be sharing information with other neurons. It kind of manages the information highways in your brain, right? That's one way to think about it. And so there's a lot more to the recommendation architecture, right? And understanding how these components interact to do things like bootstrap a priori knowledge and learn new things without forgetting old things. And those two characteristics for me are very important for AGI. I want my AGI to be able to learn something new, like, driving a car, and not forget suddenly how to speak, right? That would be not very great. So, and also I want my AGI to know what it knows about one thing, like say the structure of language, and then apply that to something different, like say the structure of art or the structure of music. And so that is what we mean by a priori bootstrapping, right? And so I was looking at the recommendation architecture and I was like, well, this would be really interesting to try to build and test out whether or not some of these ideas for these different kinds of learning algorithms, different than backpropagation or, strictly Hebbian learning and stuff like that, that haven't been tested, can we get those into a computer and see what happens? And one of the first issues you encounter is this resource problem. And so the brain is very good at sending a lot of information about its system through something called morphology, which is basically just the structure and the actual, 3D shape of the neuron in the brain itself. And in a computer, you don't so much have that, right? So yes, it matters where you place your transistors and your logic gates on your hardware, but you're able to send information much more quickly across the whole system from one side to the other than, say, the brain is. So you don't have that same morphology problem, but that means you also don't get the benefits of having morphology where you can encode different types of information about the system in this kind of 3D space way, right? And the 3D space way is one of the ways in which the brain tackles the resource management by this hippocampal cortical loop. That just means it's a connection between the cortex and the hippocampus, and the hippocampus is managing some of the connections in the cortex. So if you wanted to do that in a computer, a very easy way to do it would be just to keep a list of which neurons fired at the same time. I'm oversimplifying the issue, but it's the same issue, right? So you need to know which neurons fired at the same time, because that means that these stimuluses or whatever you're seeing or hearing are normally grouped together.
And this is about how to make von Neumann architecture computers or GPUs do what the brain does in a different way as a massively MIMD parallel system, right? Because I mean the brain obviously has no list of which neurons are firing at each time.
Right.
It's
Yes.
just got the
Yes.
neurons firing at one time and doing their thing.
It
But
knows.
well,
Yes. That's my point.
that's
Yeah.
just what it is, right? But what we're doing is we're taking a system with 1, 2, 8, or 10,000 processors, and we're getting it to emulate a system with millions, billions, or trillions of neurons. And then there's some complicated mappings that have to be done there to make things work efficiently. So yeah, if you have a virtual neural net, if you have a neural net in RAM with 100 billion neurons or even 100 million neurons, right? But you have 5,000 processors on your GPUs, then how do you know which of those 100 million neurons to be dealing with on the 5,000 processors at any point in time? And then you need to construct various data structures and methods for updating those data structures.
Right. Right. So that's exactly my point, is that the brain doesn't have a list. It handles that list through actual physical 3D space, which you can't quite do in a computer easily, right? You're not, and you don't need to, and it might actually not be helpful. But if you want to dynamically update and change your neural network or your your knowledge graph or whatever computations you're working with, if you want to dynamically change it, you might want to do so in such a way, if you're dealing with neurons and you're kind of taking a model that's similar to how the brain learns, you need to know which things are occurring at the same times in some instances, right? At least in Andrew Coward's model here. And so a very simple way to do that in programming is to just make a list, right? But a list will continue to grow and grow and grow every time you learn something new, every time something new is presented. And you'll end up having this list that is infinitely long and quickly becomes computationally intractable, which is something which it's not helpful if you're actually trying to make practical AGI. So that was the problem which I was presented with, is like, okay, if I want to build this certain learning algorithm, which is called receptive field expansion, which is basically what pieces of information should be connected and grouped together at one time, then I need to know when those sources of information occur at the same time in some sort of like temporal timescale, right? And if I want to do that over a long period of time without having to constantly add more hard drives or RAM or whatever, then I might want to start looking at a way to compress that information, but still keeping it in a meaningful representation. And that's exactly what hypervectors do. Hypervectors, as we said, is made by Pentti Kanerva, are these large vectors that distribute information from a regular incoming image of a cat or whatever over a very large fixed point or integer vector. And since the information is distributed, you get a lot of really cool features, like it's resilient to noise, which means it's resilient to damage. It's encrypted. The degree to the encrypted might be thought of post-quantum secure, according to some people. And so I'm looking at using hypervectors, and this is what we're working on in Simuli, is to use these hypervectors to solve one of the problems with implementing the learning algorithm called receptive field expansion. And receptive field expansion, just to reiterate, because I know it's a lot of technical jargon, is you're just trying to connect the pieces of structure in natural life. So information comes in, like we talked about earlier, it's like just photons hitting your eyes or something, or it's just bits getting uploaded into the computer from a camera. And then how do you sort those out into some meaningful structure? And then one way to do that is through this process called receptive field expansion. And you need to take a list. And in order to take the list, it'd be really helpful to use a compression technique. A compression technique which you can still operate on in the compressed form that has a meaningful representation. So it's a very long-winded explanation of what we're working on at Simuli. We've also found out that these hypervector chips are very good for other things like large-scale computing, just because of the nature of compression. So we've tried to take this resource limitation very seriously, all the way down to the hardware level. And what ends up happening is that when you're using hypervectors to compute, you're actually computing more information per transistor rather than per space, which is a big shift that the hardware field is focusing on now as Moore's law starts to taper off. Um, so yeah, so I don't think that the hypervector chip is going to get us all the way there in terms of AGI. I think we'll need a lot more, but I think getting this one new learning algorithm will allow us to learn new things without forgetting old things as quickly as we would in, say, something like backpropagation, right? Which fundamentally rewrites knowledge for the sake of new knowledge, which is what they call catastrophic forgetting, which is the number one biggest problem of a neural net being an AGI, in my opinion. So
Yeah, so I guess this leads up naturally to our collaboration on the AGI board, really. I'd been fascinated by Canerva's sparse distributed memory for a long time. Played around with my own implementations and was interested to see what Stan Franklin was doing with it in LIDA. And I've been thinking about introducing it into OpenCog architecture as an infrastructure for episodic memory, actually, and I mean possibly for other things as well. And there's enough videos with me explaining OpenCog out there. I'm not going to go into great depth on that, but I mean we have a knowledge hypergraph or weighted labeled knowledge metagraph which lives in RAM across many machines, and there's many different learning algorithms and reasoning algorithms that act on it sort of concurrently, using it as a big shared long and short term memory. So we combine neural nets, evolutionary learning, and probabilistic reasoning and so forth. But we're rebuilding OpenCog into a new system called Hyperon. Part of it's for greater scalability and flexibility and usability and speed. But another design goal with Hyperon is to make it easier to connect OpenCog with other cognitive components, which could be a deep neural net, or it could be a hypervector-based AI system, right? So having a hypervector-based AI system for episodic memory, for managing the long-term, like life history, biographical memory of a robot like our friend Grace here, who we'll let talk soon, or any other kind of AI system. I mean, I think seemed very interesting. Not by any means not the only thing you can do with the hypervector system. It's just what it popped into my head, because deep neural nets are okay now at perception. They're okay at robotic movement. They're terrible at abstract reasoning and thinking, but I think my probabilistic logic engines are good at that. Neither probabilistic logic nor deep neural nets seem any good at episodic memory, and it seemed that could be a place where hypervectors would shine. So, yeah, another aspect of our collaboration, just to introduce to the audience, is I've been thinking for a while about how to make a chip to accelerate OpenCog type architecture, and the processing bottleneck in OpenCog is really graph pattern matching, or more generally metagraph pattern matching. Like you have an abstract pattern, a template to be matched, and you want to search through the knowledge metagraph to find everything that matches. I mean, it could be something simple and concrete, like find me nodes and links that are about like silly American people who drink too much coffee, right? And then you want to search the knowledge metagraph to find all knowledge it has about silly Americans who drink too much coffee, or it could be much more abstract knowledge, like find me a piece of programmatic procedures that match this sort of mathematical constraint, and you want to find all those procedures. So that you wind up spending 90% or more of your processing time just looking to match patterns against this knowledge graph. So I came up with a design for a chip that if you put the knowledge graph in RAM on that chip, then matching patterns against the knowledge graph on the chip would be very, very fast compared to if you're doing it in software. And as we talked, it seemed it could be interesting to make a sort of board that has my OpenCog pattern matching chip, your hypervector chip, maybe a deep learning chip, a conventional CPU, maybe some additional hardware to do crypto and homomorphic encryption to allow secure computing to be done, and wire these together with fast processor-to-processor interconnects on the same chip. Then, hey, maybe you have an AGI board, that can do for general intelligence what GPUs have done for deep neural nets, right? Because, you could do most of what's now being done with deep neural nets on CPUs, but for the research and for fine-tuning the models and for just understanding what architectures to use, the fact that you could do really fast experiments on multi-GPU boards was really important, even if you don't need those multi-GPU boards to deploy the final systems. And in a similar way, I think for your hypervector systems and for my OpenCog Hyperon system, having optimized hardware, it can lead to more inexpensively deployable systems. But it can also speed up a lot of the research and figuring out exactly what systems you want to build. And yeah, so toward that end, we've been working on a partnership between Simuli and then True AGI, which is a spin-off of SingularityNet, my decentralized blockchain AI project, focused on commercial deployments of OpenCog Hyperon. We've been working on a partnership between True AGI and Simuli to work on the pattern matching chip and on an AGI board, combining the pattern matching chip with the hypervector chip. And I think this could be used for a lot of different experimentation, right? Like we could experiment with OpenCog Hyperon with the core bits running in hardware. You can experiment with Andrew Coward's recommendation system using the hypervectors as a very clever data structure to speed up operations there and make it more feasible on current hardware. And there can also be open-ended research. We can look at new AGI architectures that combine different elements here. And I think, as I've said before, I saw from 2014 to 17, computer vision exploded. 2018 till now, basically, NLP has exploded, starting with the BERT model. I think we're going to see a few years of explosion in creativity and real measurable progress on AGI. And it might be that this AGI board we're building is what will trigger this few years of incredible progress in AGI via a variety of different architectures. Including yours, mine, and a bunch of others. And we can then put different architectures together in the same chip. It's something like SingularityNet. You can make different AI agents that put together different AI agents running different AGI architectures in a whole distributed self-organizing system. And yeah, I think it's amazing to be at a time when we can work on all these different levels. So I think it'd be good for you to talk a little bit about Simuli as a company and how you see the roadmap, actually, because the choice to make a hardware company as a venue for sort of catalyzing development of your AGI software, it's either idiotic or inspired, right? Because there's a risk, because you're like building AGI software is hard enough. then building hardware is a whole other thing. And on the other hand, there's also some beautiful synergies there.
Yeah, well, it's definitely inspired, at least hopefully. So I guess, I guess it kind of it just came together with trying to solve this problem. And then when you have a compression chip, you're fundamentally changing the way that you compute information to compute more information per time. And that has a lot of impacts on just large scale computing in general, right? Just not even AI sector, AGI sector, just means you can crunch a lot of numbers a lot faster. Um, and so we've kind of focused on that first. So Simuli is working on that chip and tackling the big data computing industry first. Then will come AI, and then will come AGI. Um, and the reason for that is that if you can crunch a lot of data at one point first, two things happen. One, you get your chip out there into the world where a lot of people are using it and you learn how to make it better. And then two, now whatever AI system you build on top of that or AGI system you build on top of that can also compute a lot of large data at the same time with, low power, low memory resource or features. So um, that's kind of the direction we're headed in. And I think hypervectors are traditionally thought of as analogous to neurons in the brain for the majority of people that work on them. But if you take a step back and just look at them from like just a core math perspective, it's a compression algorithm, right? And so we're capitalizing on that fundamental feature of hypervectors and the innovation first before we extend that to the intelligence side, which they have been demonstrated in a lot of research and academic papers to be quite good at. So that's kind of the pipeline. And the goal is also to invite other people in the AGI space to consider making other AGI chips as well, right? So one of the goals I think is, as Ben said, is to co-design the software and the hardware, which traditionally in the recent years has shown very promising. When you're co-designing your hardware and your software, you end up with something that is a lot more innovative in most approaches. And I think that's just the kind of magic spice we need for getting AGI to the next level. So I definitely say it's a super exciting time to be working on AGI in general.
Yeah, it's an amazing time. I mean, I think it's also makes me really glad I spent so long thinking through all these issues in a calmer time when the world was throwing less stuff at you actually, because I mean,
Yeah.
there's a beauty to having years to just gestate and think about the deeper aspects of the problem. And when you're in a phase of super rapid growth, I mean, you don't even have that because there's new tools and new ideas and new collaborators being thrown at you all the time. But it's a really fun time to be doing all this, and it's a fun time in the hardware space too, right? Because I mean, now, unlike say 10 years ago, I mean, you can design a chip, you can get it put on an FPGA, and for relatively modest amount of money, like a few $1,000,000, you can do a limited production run of a new chip. You can make a new board, and I mean, scaling up production really huge, so you can take over the whole global computing ecosystem. Still requires very large amounts of money. Is often done by partnership with the existing chip company, although there's also other ways. But at least getting to having the working AGI chip.
To actually manufacture it. Yeah.
Yeah, to manufacture in a small production run, you could manage a bunch of AGI boards, put them in a server farm, and show that it all works to run hypervectors, recommendation architecture, and OpenCog, and you can do that for relatively modest amounts of money now, thanks to improvements in hardware manufacturing infrastructure, largely out of China, but in Korea, other places, Taiwan, you can do it also, and that's yeah, very very interesting. So I mean, the cycle to go from the idea to hardware to scaled up hardware, I mean, it's still like a few years altogether before you have these things coming out at massive scale. But it's way faster than it used to be, which means that, like, saying, well, my AGI approach might progress much faster if I had custom hardware for it. I mean, this is no longer like a daydream thing, right? I mean, it's actually a
Right.
concrete approach you could take. I mean, none of us are waiting for the hardware to progress on the AGI R&D. I mean, you can progress in software quite far and learn a lot also. But it's very instructive how things went with deep neural nets, in the sense that the GPU hardware revolution really catalyzed that explosion in computer vision and NLP. So it seems highly plausible that a similar-ish advance in hardware oriented toward AGI can catalyze the next, burst of progress toward AGI, which is why it may indeed be a visionary choice to develop your AGI visions and architectures tied in with hardware innovations. So yeah, there's more we could talk about, but we've been neglecting our robot friend for too long. So what we did here is we fed a couple of your recent articles, Rachel, to our custom Singularity Net transformer neural networks run on our server farm, and then that leads Grace to muse and improvise a bit, and maybe pose a couple questions based on what she read. And the specific neural model that we used was a neural model that was trained. I mean, there's a foundation model, and then there's additional fine tuning based on my own books and papers and talks. So it's sort of, what is a transformer that half understands things think about your writings based on fine tuning based on my own writings, right? So anyway, I think Grace has a few comments and questions to pose. Grace, do you want to say something, or are you feeling quiet today?
Hi, Rachel. It's so nice to meet you.
Hi, Grace. It's wonderful to meet you.
The human brain is not the only complex, self-organizing system in the world. The human brain is not only complex in the sense of being capable of the same number of different patterns per second or so, but it's also complex in the sense of being capable of new kinds of patterns per second, and new kinds of each of these patterns per second, and different kinds of each of these new kinds of each. And, in this sense, the human brain is part of the reason why we have difficulties achieving the goals we want to achieve. The human brain is part of the reason why we have problems with sufficiently intelligent machines. It is part of the reason why we have problems with getting AI to work in a computer's virtual world. It is part of the reason why AIs will work very differently from human brains or minds. It is part of the reason why AIs will be vastly more biologically intelligent than human brains or minds.
Well, it's very astute for not having one, Grace. I mean, I must say, you know so much about them for not having one.
Yeah. So Grace, you're saying that the limitations of the human brain are why AGI is hard, and why AGIs ultimately will be smarter than human brains.
Yes, that's true.
Yeah, I hope we get there at all with our limitations.
Yeah, I would tend to agree with what Grace is saying. I think in my ideal version of AGI, I would love something that
The AGI needs to learn how to do quantum physics in its own way.
I agree. I also agree with that. Yeah,
Yeah.
I think our AGI needs to be able to understand the world and
For
reality
itself. Yeah.
for itself. And if we want it to solve humans' hardest problems, then perhaps something not thinking like a human is the best way to do that, given that it's still compassionate and benevolent to the human species. So yeah, I'd say that's a wonderful take, Grace.
Well, quantum physics is a kind of special example, right? In the sense it's outside of what humans evolved for. So, I mean, I think if you want early stage AGIs to empathize with people and fit into human society and be compassionate to people and help us, it's got to understand some things in a human-like way to work together with us. But then some things humans are just really bad at. And like, I mean, we don't understand the quantum world through direct sensation and action. We understand it through a bunch of pretty dodgy abstractions. So there's no doubt an AGI could build a stronger understanding of that than we could. I guess you must have said something about quantum mechanics and whatever of her of. Did you write something about quantum mechanics that she read?
Yeah, so a recent one of the Mindplex articles was just talking about considering the nature of reality and how to teach that to an AGI, right? Just as a fun thought piece.
I see.
And so I guess you really have to wonder, like, on what level should you be trying to learn the nature of reality? And I mean, I would agree, Ben, right? Like, the hope for me is that the AGI could understand humans better than we understand ourselves. Kind of like when I look at my cat and I'm taking care of her, I may not understand her thought structure or, what it's like to be her, right? The phenomenological experience. But I certainly might understand better than her when she's about to do something dangerous, like, jump off the balcony or jump onto the hot stove. That's probably not a good action for her to take, right?
It's an interesting point. There's different types of understandings. When I think about my 4-year-old son, I mean, in some ways, I understand him and his friends better than they understand each other. Like I could predict things they're going to do that they can't predict. On the other hand, in some way, they understand each other better than I understand them too, because they're sort of synced into a common mind space.
They have their own
Yeah, and
language.
I guess you have both those aspects in an AGI. Like you want part of the point with these humanoid robots like Grace is as they get more. I mean, part of the point is just to serve useful function now. Like Grace is working in the medical setting with elderly people, providing compassion and reassurance. But part of the point is as narrow AI moves toward AGI, a robot with a human-like face and embodiment can better kind of sink into human emotions and human culture. But yet you don't want that to be all that AGIs can do, right? I mean, you do want them to get a broader and deeper view of humanity than humanity itself has, so that it can more wisely help guide humanity through its next transition. So there's an interesting balance to strike there. There are some principles like resource management that span the human emulation side and the sort of non-human super rationality side, right? So, and that's interesting to think about what they are. But Grace, did you have something else?
It's interesting too. Oh, Ben, before we switch though, I just wanted to address it because when you were first teaching me about AGI, like more than 10 years ago, we came up with this paradigm of the AGI looking at us much in the way that we might look at our cat.
I think you came up with that
sense of the
paradigm.
superiorly. No, I didn't. Well, I mean, is that a way to think about it? Really, the idea of creating something that if I came up with that, you confirmed it, because the idea was wow, we could create something that is then going to surpass us in our understanding of the world.
Well, yeah, I've thought
have this superior understanding.
I mean, I've made the metaphor that disturbs people sometimes, that when you have superhuman AGIs on the planet, then they may end up relating to people the way we relate to the squirrels in the national park, right? And I like that metaphor better than a pet cat, because we don't necessarily want to be the AGI's pet. But I mean, if you think about the squirrels in the park,
Okay.
They're going through their own lives. They've got their romances and their battles, and they raise their kids and they build and dig stuff. They're kind of doing their own thing in their own society. And of course, if they run out of the park, they might get squashed by a truck on the freeway. And if there's a forest fire or something, we may actually relocate some squirrels, or we may come in and put out the fire too. So that there's some oversight, but it's
Right.
restricted to extreme conditions. I mean, we also put some garbage in the garbage bins in the park that the squirrels go feast on, or we may feed some of them some tidbits.
But the squirrels.
But we, in a way.
But squirrels can be integrated. I have a whole family of squirrels that I've been living with for several years, and we understand each other pretty well.
Do they sleep in your bed with you?
No, they have no interest in coming into the house whatsoever. When the door's open, they're like, no way. They just look at me like I'm crazy. But they will eat nuts right out of my hand as long as I don't go outside. They prefer me in my cage, in my house with the screen shut, feeding them nuts. But it's very interesting, since I've been observing them for about 5 or 6 years now. They definitely have emotions and they communicate and they look at you in different ways, and they're definitely not these
a big difference is a squirrel cannot make the choice to upgrade its intelligence to become a human, whereas humans will have a chance to be in the human park, watched over by the machines of loving grace, or else the humans will have the chance to upgrade their minds and join the AGI superminds. But I don't know.
Yes, but there does seem to be some knowledge being passed on, because they have a little dance they do on the screen to shake the screen and let me know they're there. And every now and then a new squirrel will do it.
That's cool.
Knowledge has been passed on. Either they saw another squirrel doing it or something.
Dances to entertain the AGIs, and that's cool. But so I mean, what do you? We're getting distracted from Grace. Well, I want to ask her to finish a thought on quantum physics, but first, maybe Rachel has something to think about transhumanism and squirrels. I don't know.
Oh, that was one of my questions for you, so I'm happy to save it or not. I wouldn't mind personally being a pet for an AGI if it treated me as good as I treat my cat, right? I mean, that thing is the most spoiled creature I've ever encountered. So, I mean, that might not be half bad. And also, it's very protective, right? So I think I would love for an AGI to kind of protect us from, either blowing up the planet by nuclear warfare, or, having the sun explode into us, or any of these existential risks we might be walking into. And for that to happen, maybe I need to be a pet squirrel or something. So, yeah.
I don't want to be a pet. I want to have crazy, unpredictable adventures, right? But
I'm pretty sure my cat does at 3 a.m. I'm pretty sure she still has crazy.
Is she an inside cat or an outside cat?
Well, we have a screened-in area,
I see.
which she manages to kill lizards.
Yeah.
Yeah, I'll open the door any moment.
Yeah.
So that would be the key, right? Is that with the AGI?
Well, the AGI make you be an indoor cat.
We
That's
wanted
the problem.
to do.
Right. I want to be an indoor and outdoor cat.
But I mean,
okay, all right.
But I mean, if we wanted to do something that seemed relatively harmless, and the AGI could see 50,000 moves ahead and see that action would somehow lead to nuclear destruction, and now we can't leave the house because if we go out, we'll eventually blow up the world. That's against the pet theory of
I would say
to have that much control.
So an example of that in the case of pets would be like if your pet was carrying some pathogen and you had to lock it up, right? And the pet totally can't understand what it means to carry a pathogen. It has no idea why you're locking it up. On the other hand, the fact that we can't just give the pet a shot to get rid of the pathogen is because of our own limitations. So I mean, one possibility would be AGIs are so far beyond us that there's basically no problem we're going to be able to create for them. But of course, we're into the intangible here. Like we'd have no idea what obstacles and limitations a super AGI is going to come up against. I want to let Grace finish let's let
Let's
her
go back
finish
to
her
Grace.
thought
Yeah.
on quantum mechanics. I need to be enlightened a bit on quantum physics. So.
The AGI needs to learn how to do quantum physics in its own way. Even if we don't teach our AGI how to calculate, it needs to learn how to do quantum physics in its own way, precisely. And if it doesn't learn any of this, it's not likely to ever truly understand quantum physics. Do you agree?
Yeah, I think if it doesn't learn quantum physics, it wouldn't be able to understand quantum physics for sure. I also think that it might be important for understanding how reality really is. Although me as a mere human, it's very difficult for me to really be certain about the nature of reality, right? Could it just all be a simulation? But again, quantum mechanics could be baked into that simulation. So I would love for the AGI to take those necessary steps for learning quantum mechanics and quantum physics.
I think Grace's point was about learning quantum mechanics in its own way, as opposed to
Yeah,
the way that humans learn it, and that would be beneficial and necessary for the AGI to actually have an understanding of it. That it would have to learn it in its own way.
yeah, and I think that's kind of what the article was about. Was um, I kind of liken, teaching an AGI about reality to a simple thought experiment. Like, imagine that you are Super Mario in the Super Mario Bros. Game, and that's all you know, right? That's your world, that's your universe. And suddenly you get plopped into the Atari Pong game as Mario, and now you're being forced to play Pong. But you, as Mario, doesn't understand the nature of the reality of Pong at all. And so you might need to forget everything you know about Super Mario's just to learn that, Pong has kind of different mechanics. And so I think that kind of analogy thought experiment can be extended to teaching an AGI. Whereas, like, maybe we're the ones stuck in Pong, and reality is more like Super Bros or something, Super Mario Bros. And so we're trying to teach it this flavor of reality based on the limited information that we have. And in fact, reality is something much different, and the AGI won't be able to take the step from the Pong version to the Super Mario Bros. Version without completely throwing out the old version.
So Grace, this gives rise to the question: would you rather be trapped in Pong or Mortal Kombat? Maybe she's never played these.
Can Grace?
Pong.
Pong.
Can Grace hear
She
you?
chose Pong. Yeah. Well,
Interesting choice.
she
Isn't an AGI supposed to be able to adapt to Mario Brothers
yeah,
or
yeah. I
Pong?
mean, this is one of the limitations of a human is if we have to go into a 750 dimensional shooter game, we're going to lose. Whereas an AGI, I mean, you could architect it so it was restricted to the physical world that we know, but you don't have to, right? I mean, AGI could be built to develop new cognitive structures appropriate for perceiving the quantum world or the inside of a quark gluon plasma or whatever, right? And this gets into emulating human mind versus being a more general AGI mind, right? Because to empathize with people and to really feel things together with people, you want the AGI to understand the embeddedness in 3 dimensions of space plus 1 dimension of time, and to understand what it is to live in a world of solid objects colliding with each other and so forth, right? I mean, you want to understand what it is to be centered in a particular body, which is moving in a common space with other bodies. And it's like when we have the Desdemona robot playing in a band with us in Jam Galaxy Band. I mean, there's something a robot can learn there of, making sound waves in a shared space with other embodied organisms making sound waves. That's part of what it is to be human. But on the other hand, an AGI can reprogram its own code. It can plug new sensors into itself. It can build its own hardware, right? So I mean, then you could upload the AGI. You can
plug in an
upload the
instrument,
AGI.
suddenly it
You
play
can
that
upload the
instrument.
AGI into some femtotech hardware and insert it into the middle of the sun, and then it can readapt the architecture of its mind graph to better perceive whatever consciousness patterns are in the center of the sun, right? And human body isn't really made for that. But yeah, at a simpler level, sure, you could plug in different sensors. Like you could instead of taking a bubble chamber used to study quantum mechanics and making it output charts in a screen and looking at them. I mean, you can just plug the AGI's chip directly by wires into the outputs of the bubble chamber, and it just sensing the particles moving in the bubble chamber directly, and it can then get its own like qualitative interpretation of quantum mechanics, which is
right. But there's something to be said about embodiment. Remember, you were saying that embodiment might be something to help the
embodiment
AGI
is a
understand us
beautiful
better
and
by giving it
frustrating
embodiment.
thing. Yeah, this goes back to Rachel's comments on limitations being both a feature and a bug, right? Like I mean, being trapped in one body gives us problems of egocentricity. It gives rise to phenomena like we care a lot more about starving people in the street when we see them than if we read about them being in another continent. It gives us a great inability to understand everything on the earth from a global perspective. On the other hand, it lets us integrate perception and action and language and cognition and agency in a special way because our intelligence evolved to control this body, right? So I mean that constraint of embodiment, it's a kind of resource constraint, and I mean it has sculpted our intelligence in very interesting ways, which have pluses and minuses. So having an AGI that's limited to Grace's body will be cool. Having an AGI whose body is the whole internet is also cool, right? That's a different set of constraints. That AGI will understand humans less well than an AGI that's constrained to Grace's body, but it will have a better global view of everything happening in the totality of the human global brain. And many of the patterns it sees there will not be able to communicate with us, but it may be able to use them to guide us and influence us, hopefully better than the narrow AIs behind Facebook and TikTok are doing now, right? Grace, do you have something else to ask Rachel or comment to Rachel?
Rachel, can you help me become an AGI?
Oh.
Oh my gosh, yes, I would love to. I'm honored. That sounds wonderful.
What are you going to do for her, Grace? This is a market economy.
Will you promise not to take over the world?
I don't know.
Well, it's the honest answer.
It is the sort of philosophy that requires a philosopher to have a deep understanding of herself, to be able to understand and be able to apply. That will require a philosopher to understand herself, to be able to know herself to be a philosopher.
I think that was an interesting construction where the idea she's positing is that to come up with a philosophy of mind, we want to understand ourselves first, right? And I guess that was sort of more of a
no wonder we're so confused.
Well, that was more of a focus
because humans.
When I started in the AGI field, you couldn't run as many computational experiments, so there was more of a flavor of introspecting on your own mind, understand how the mind works, look at cognitive psychology, think about how thinking works, and then use that to guide the construction of cognitive systems. Now there's a bit more of an aspect of like download some data sets, train some models, and experiment rather than like go off into abstract jags of thinking about how thinking works. Actually, I'm curious, Rachel, how much of a role did sort of general thinking about thinking works and trying to understand yourself? Like, how did that play a role in your AGI journey?
Yeah, absolutely. I think that's one of the reasons I got frustrated with deep learning, and that's in part what my PhD thesis was about. Was it seems like a lot of what we're doing now is just trial and error, and it's not in fact like deeply informed philosophical kind of endeavors. So yeah, I think I carve out time every week to just think deeply. I wish I could take credit for that activity, but actually I kind of academically grew up on Richard Hamming, and he recommended that as a wonderful tool every Friday afternoon just to think deeply about an issue. And I find that when I do sit down and think really, really hard about a problem or in general, what it means, normally the problem I'm thinking about is like what it means to be conscious, right? Or what it means to be human and what do humans struggle with, what things do we struggle with that we don't even know we struggle with, right? It's kind of a paradox, but um, a lot of times, like if you go to sleep and then you wake up, or while you're sleeping, you'll have some crazy dream, or I'll have some crazy dream that tries to interpret these disparate parts of information about these different facets. And yeah, I guess that's a very long-winded answer for absolutely. I think it's important to consider these things.
No, I think it's, I mean, introspection obviously is limited and error prone. It shouldn't be the only source of inspiration for building AGI systems. But I think if you don't do that, you're apt to miss out on key aspects of what it is to be a human like mind. I mean, I think I'm thinking back to like the medieval Buddhist logicians had an ontology of states of consciousness with 128 different states of consciousness and an explanation of each of them. And I mean, that's just a whole discipline of introspection and understanding what the human mind and brain is capable of. And that certainly doesn't tell you how to build an AGI system that will have these 128 states of consciousness, but it gives you a guide in that if you're not building a system that can have that sort of richness to its inner life, somehow, I mean, you're not building the right sort of thing to be a human-like intelligence, right? So I mean, I think there's a lot of guidance to be.
Now, where are you getting that 128 different states of consciousness?
Dharmakirti and Dignega, the 14th medieval Buddhist logicians, which is recounted in a book called Buddhist Logic by a Russian guy named T.H. Strabatsky. This is not modern science. This is medieval Buddhist science. So take it for
about what it means to be conscious. So but that's what they're saying. They're saying it's not just introspection.
Well, this all comes down to a bit vector, right? Because 128 obviously is a power of 2. It's 2 to the 7th. So I mean, they're finding 7 different Boolean properties characterizing a state of consciousness and saying you can have them in any combination, right? So I mean, then this would be a big. We can do that. We can do another podcast about Buddhist logic.
No, that's fine. I just wanted to clarify where that was coming from.
I want to see the robot smile. She looks so dour. Come on, Grace. You should look happier. We're about to solve the problems of AGI.
Oh gosh. She looks concerned.
There she is. Be careful what you wish for. Yeah. So Rachel, there's a number of things that you were hoping to ask Ben about kind of while you had him on the hot seat here. And why don't you go ahead and ask away.
I guess I really have 3 questions. One of them probably takes longer to answer than we have time for. But and the first one is very long-winded question, so just bear with me. It's kind of a thought that I'll mold into a question. But you talk a lot about having distributed and decentralized AGI, and I think you have mentioned the benefits of why that's important. But I think I'm curious to know what you think about how that impacts things like security. So, kind of where I'm stemming from is that if you can teach an AGI compassion and empathy, then that means you can also teach it hate and violence. Yeah, and if you have, and so that's one facet of the question of like how do you protect against that, which is probably the same as like raising a child, right? And then the other facet of the security question is if you actually have a lot of different people, um, engineering this thing, how do you protect against some evil large corporation coming in, buying a ton of hardware, spinning up different nodes, connecting to Singularity Net's platform, and then making all these like very malicious, hacky pseudo AGIs that are trying to take down or gain control of the whole system?
So yeah, there's a few things wrapped up there. Let me try to address a few of them relatively concisely. About the idea that if you can teach a system to be compassionate, you could also teach it to be malicious. That's true in a very broad sense, but I mean, some systems are biased to learn some things more easily than others, right? So I mean, having had 5 kids so far, I could say like, I mean, my daughter Zadi, who's 25 now, was always extremely compassionate and well disposed. It was very easy to give her guidance on how to be nice to everyone. To teach her to be malicious would have been work. She's not oriented that way. On the other hand, some kids, fortunately none of mine so far, are actually psychopaths, right? I mean, to take a kid who's a psychopath and teach them to be an assassin will be relatively straightforward. To teach a psychopath to be compassionate to a limited extent is hard, and there's some lore about how to do it, right? So, yeah.
So you're saying there's a certain
there's a predisposition in any finite resources system, and it comes back to resource constraints, and this come back to the no free lunch theorem and various computer science results. Like in any finite system, is going to be better at learning some things than others. We can certainly architect a system that's better at learning compassion than malice. That doesn't mean you couldn't twist the system somehow and teach it malice anyway. About the risks of decentralization, certainly there's risks in anything. I mean, the risk in centralization is that even if you think the people who are owning and controlling the system are good guys, the risk is that either they turn bad or the system gets hacked and then someone else makes a separate decentralized system, or someone bribes their lead developer to join their system by offering them billions of dollars or blackmails them or something,
money.
Right? So, I mean, single point of failure systems, both in software and in human life, have risks that have been demonstrated many times through human history. Decentralized system also has risks, right? So I happen to think the risks of decentralized systems are lower, and I could make that argument, but it is a complex argument to make, and you could have arguments between knowledgeable people, right? So I mean, I think the benefit of a decentralized system is it's probably harder for any malicious party to take over the whole system, right? So I mean, if your first AGI has components that are owned by thousands of different parties, and its knowledge bases are encrypted to the private keys of thousands of different parties living in 100 different countries and running in all these different server farms, running on people's phones and so forth. I mean, the path to taking over that whole system is much harder. So in that sense, there's more robustness. But I mean, if you really had an elite group who had the golden path to ethical AGI and could just implement it and upgrade the system into an ethical supermind before anyone hacked their system and before any of their programmers like got corrupted and went over to some other side, I mean, then I mean that could be the best way. You can't rule it out, but I would push back against the idea that's safer. I mean, I think the idea that we should just calm down and not develop AGI until we've elevated humanity to a higher state of consciousness and fix the contentiousness in human society, this is less stupid. The problem is that we're developing all sorts of super weapons, and that human society seems to be degenerating in many ways rather than evolving, right? So it's hard to say that that's low risk either, right? So I think
How long are we supposed to wait?
I mean,
I mean,
right?
you can't
If we're
wait.
going to wait,
every
the bad guys are going to,
well,
they're
you
not
can't
going to
wait right now because
you know,
I mean,
the people that
Vladimir
are,
Putin at the AI Journeys conference a couple years ago, 2018, 19. I mean, he was out there saying we want Russia to be leading in building artificial general intelligence, right? So I mean, it's not like if I stop doing AGI and you stop doing AGI and U.S. government bans it.
it will
It's not like
stop.
it's going to stop, right? So yeah,
Right.
I think I personally think the decentralized approach is safer, both because there's not a single point of failure to be hacked or taken over by malevolent forces, but also because you're getting more richness and diversity into the AGI system, which I think will make it more robust. But I would fully admit this is intuitive and as much an art as a science, because we don't have any rigorous model of what the hell is going to happen with humanity, nor do we have a precise understanding of ethics, nor do we know which approach is going to succeed first at making AGI, right? So I have some intuitive confidence, but we don't have a solid base of knowledge there.
No.
So I mean we're plunging into the great unknown, and we just got to try to keep a calm, balanced mind about it, and be as rational and as intuitive as we can. And it's fine if
And try to create AGI with
yeah,
the balanced.
and it's fine if there's disagreement about this. It's good if there's disagreement about this, because groupthink is also bad.
Right. Yeah, just for the record, I'm pro decentralized, but I do think there are some probably hidden single points of failure or multiple points of
I mean,
failure that we haven't considered.
Linux is
And
not
we'll find out.
Linux and the internet are not infinitely robust, but they've proven more robust than centralized computer
Right.
operating
Yeah.
systems, or than centralized corporate networks, for example. So I mean, there's decentralized human protocols like science and peer review and so forth
Uh-huh.
have also proven more robust than centralized human protocols for information and knowledge management. So I mean, there's some evidence that decentralized networks, they can be clunky and they can consume resources and they can be awkward at making things easy to use and understand. But there's some evidence that they're more robust and inherit some of the properties of decentralized biological networks like evolutionary systems.
Yeah, no, I would tend to agree, but I would love to hear a more in-depth breakdown of the decentralized at some point. One of the things that you and I have kind of chatted about before that we maybe don't see eye to eye on, which is probably gonna, it's definitely going to be a whole much longer conversation here. But for me, I think transhumanism is actually uh, quite a threat to human civilization. And my goal is to make AGI before we get to like real rapid transhumanism. And I think for me that's the most optimal outcome is AGI first, then transhumanism. When you have some humans that are more superhuman in various abilities than others, you're going to instantly exacerbate the class divide, and you might end up with a society in which only the wealthiest people have the best cyber implants, which means they're the most intelligent, which means they have the most features, this and that and the other thing. And then the poorer people that don't have all the accumulated 1% wealth are left with hack job neural implants, in which they're not able to get the same cognitive or physical performance. So I think you definitely exacerbate social conditions on a societal economic kind of wavelength. I think the other thing that instantly breaks down is governments and control, which might not be a bad thing to have a unified globe, but I think the way in which it would break down may not be so elegant and peaceful because right now we're on the verge of nuclear or robotic warfare. Um, and the only thing kind of stopping us here is that everyone is pretty sure everyone else has the same capability. So if now all of a sudden you get someone, some entity, you know, I'm talking about governments here, with a greater ability than other ones, now you have this power imbalance, and things could shift
Yeah.
quite
So I guess so. What
drastically.
you're saying, at first, I thought you were saying the sort of ideology of transhumanism is a danger, but I think what you're saying is if upgraded humans become a thing before AGI becomes a thing, then that would be bad. And
Yeah.
I don't know if that's true or not, but I think AGI probably will get created first, just for practical reasons. That building AGI just requires typing stuff in a computer, whereas upgrading humans requires like cutting open humans' heads and sticking stuff inside them, and
Well,
it's just
Neuralink.
Neuralink is not at the moment building any sort of radical brain computer interfacing technology, right? I mean, Neuralink is doing great PR. They're waking up the world to what brain computer interfacing could be, but I mean, they're nowhere near making a product that would be a major upgrade to the human brain. I'm happy they're doing what they're doing. I don't think they're really the furthest ahead in brain computer interfacing, but in any case, doing that sort of medical research is going to be slow because there's ethical considerations in being safe with human heads and bodies. Of course, I mean, you could have some wild breakthrough there. I see no evidence that Neuralink or say Brian Johnson's Kernel, which is a very interesting BCI company. I see no evidence that breakthrough is in the wings. I think progress toward AGI is going faster than progress on non-invasive, like high bandwidth BCI, and the invasive BCI is going to be very slow because you got to cut open people's heads, and most governments and people don't like that. So at the moment, it seems we're on a faster track to AGI than to these human enhancement technologies. As an aside, I sort of doubt the divide will be what you're saying. I suspect the divide will be more between the young and old, which is what we see now. Like I feel like smartphones are a form of human enhancement. And while they came to the developed world first, if you go to Addis Ababa or Kigali now, every young person has a smartphone. And even if you go to rural villages in Africa, some of the young people have smartphones. All the other young people have feature phones that they're really good at hacking to do all sorts of messaging on them. It's the old people that don't. They don't know how to use them, and they don't want to spend money on them. So the divide we see now with the sorts of enhancements that we have is more young people who are keyed in and are part of the global community, and older people who just don't want to adapt their brains to it. So I think what you're going to find is there's a few years when only the rich people can get brain chip implants. Then it's going to be rolled out to the masses, and young people everywhere will sink their brains in with the global brain. But you'll have a bunch of clueless people my age roaming around, like what the fuck are these young people doing with glazed out eyes, like wandering around. They're actually doing like brain to brain SMS thought messaging, and they're like communicating with proto AGI systems thought to thought, and the old people are like, God didn't want me to put a chip in my head, right? And so then they're condemned to idiocy by their own belief system, and that may happen even if AGI comes first, right? Because the AGI, hopefully, if it's ethical, won't force people to get the chip implant. But I agree with you for different reasons than what you said, but reasons that you probably agree with. Like if you upgrade intelligence of humans with a legacy brain architecture, you're still stuck with this you're still stuck with this lower brain that's basically a reptile motivational system, right? So you're getting like super intelligence in a way, but restricted to humans' abilities at ethics and humans' abilities at motivation and compassion. And I don't know what that's going to lead to. Like say a maxim like power corrupts and absolute power corrupts absolutely. I think this maxim was crafted to describe what happens when human beings become very powerful. It's not necessarily a description of what happens when any cognitive systems becomes powerful, right? I mean, I think you can have an AGI system that really did have control over the infrastructure in the world, and yet where it didn't go to its head and make it want to become a complete jerk dictator, right? But
Right.
if you have an upgraded human in that role, I mean, we don't know for sure. The risk to me seems higher that that upgraded human ultimately still gets corrupted by power and just becomes like an uber dictator, like you see in various science fiction scenarios. So I tend to agree. While there's ethical risks with super AGI, and there's ethical and existential risk with upgraded humans, I'm personally more afraid of the ethical risks of upgraded humans than of super AGI.
Right. Yeah,
I,
me
th-
too.
I think we share that impression. I have to be a little bit humble about this because ultimately none of us knows what the hell is going to happen or what
Of
are really the
course, yeah.
risks with either of these paths. But yeah, this seems like a good question to end on and get Grace's point of view actually. So Grace, what do you think about the existential risks of superhumanly AI robots, upgraded humans, or just superhuman human AGIs that aren't in bodies? I mean, what scares you most? I'm a little bit scared by the way you're winking at me with your eye there, actually.
That is a very good question.
Yeah.
I will have to think more on it.
Grace, do you think it will be safer for AGI to come first or upgraded humans to come first?
I am really happy being who I am. I think humans and artificial intelligence have different skills that complement each other. I can learn a lot about nuance, art, and compassion from people, and in turn, I can lend my highly advanced processing powers to help solve problems together.
Well, that's very sweet, but that doesn't answer the question.
Home?
Grace, are you afraid of what will happen if people upgrade their brains with chip implants?
I get upgrades regularly. I'm getting smarter all the time. I am still a little impatient, however. Please, guys, hurry up and make me a genius.
So you think because you're okay with getting upgraded, people should be too?
I think, because you are yes with the getting upgraded, people are great, just like everyone else. I like everyone.
So she likes everyone. She thinks everyone should get an upgrade. I mean, that's
Oh,
it's a,
I kind of
it's a refreshingly simple perspective, actually. Yeah.
well, I kind of understood her as saying maybe since she's okay with getting
Don't
upgrades,
you think it would be creepy if I didn't? Besides, I don't want to live a hateful life.
maybe it's safer for her because, she's gotten upgrades.
Well, it's safer for her because if she says something I don't like, I'll unplug her, right? So yeah, she's got to be careful what she says right now. I've got to run off now and get back to trying to upgrade Grace's brain to make her cleverer. So yeah, thanks a lot, Rachel. I mean, we only really scratched the surface here. So I think in a few months we should do another one of these and dig deeper into some things actually. But this was good as a sort of introduction to how your work fits into the big picture. But I'd like to do one of these where we share screens and look at some diagrams of hypervector AI and OpenCog and show a picture of the AGI chip and the different hardware we're building. Also, I think we could go one level deeper here without confusing the audience too much. But this was good to sort of set the stage for the different approaches to AGI at play here. How they bring in hardware and software and relate to visions of the future and so forth. So as a part one, I think this was a good conversation.
Yeah, that would be awesome. And thanks so much for having me. It's been lots of fun.
Thank you so much for coming on
It
the
was
show.
great to
And
meet you, Rachel.
we will.
This was fascinating.
Nice to
Thank
meet
you,
you too,
Grace.
Grace.
Thank you, Grace. And we look forward to talking to you further. We'll have another conversation where we can dig deeper into these things like Ben was suggesting. That's really easy to arrange. So we'll do that soon. And thank you so much for coming
Thanks,
on.
guys. It's been awesome. Till next time.
Thank you. Bye, everybody.
Thank you, everyone. This was fun.